Is that okay with you, Dr. Hoffman, if we record?
Absolutely, no
All
problem.
right, great. So I already mentioned we're joined by our brand new group of 2025 N3 scholars. Welcome to the program. This is your first monthly meeting that you've been invited to, and we'll have these every month until the end of our grant, which is December 2025. So you'll get one invitation per month from now until December. Um, all right, and I have a super quick icebreaker. If everyone wants to boost their confidence and share something that they love about themselves and maybe something that they're working on. And just a heads up, if anyone is unmuted, I'm just going to go ahead and mute you so that when it, excuse me, comes time, we can hear our speaker loud and clear. I'm not going to read all the chat responses out loud, but I encourage you guys to do so we get to know each other a little bit better. We have a diversity of likes. Some of them are skill-based, some of them are about your personalities, and that's great. Mhm. I'll give one more minute for this icebreaker. So if you're still typing, go ahead and finish up. Alrighty. So just some ground rules as we get ready for our guest speaker. And if you're still working on your icebreaker prompt, please, take your time and finish it up. We can always go back in the chat and look. But during the presentation, please don't interrupt our speaker out loud by unmuting yourself. If you have a burning question, you can leave it in the chat or at the end. I'm sure we'll have time to ask our questions. You can use the raise hand function when it comes time to ask questions. It's a big meeting and sometimes it gets overwhelming if folks, blurt out questions and comments. So the chat is there for you. We'll make sure to answer questions, all the questions in the chat, and we always have the raise hand feature. All right. So, Professor Kaminsky, would you like to introduce our guest?
Yes, I'm absolutely thrilled that my old colleague, Jeff Hoffman, agreed to come and talk to us about his experience as an astronaut. Jeff was a postdoc when I was a grad student at MIT back in the late 1970s and early 1980s.
That was a while ago.
That was definitely a while ago. And then he left MIT to go off and become an astronaut, which he did for a really long time. And he's going to tell us about that part. And then he came back to MIT, where he's a professor of practice in the aeroastro department, even though he is actually a physicist. So I guess if you are an astronaut, then you're allowed to do aeroastro teaching. Anyway, he'll tell us more about that too, but I'm sure you're going to want to hear more from him than from me. So I will turn it over to him right now.
Okay, well, thank you, Lynn. Nice to see you. It's been quite a while. What I'm going to do is share my screen so that we can look at the slides. And here we go. Okay, can you see my slides now?
Yes, we can.
We
But you
can.
might want to go into presentation mode. You're
Um,
in, you're
that's
in,
what I
you're
will
like
do. Yeah, hold on.
on slideshow.
Yeah.
There we
Okay,
go. Perfect.
so you know, sitting, you've seen the TV picture of me here in my office at MIT with my white hair, what little hair is left. So I realize I don't look like a traditional astronaut right now. So you'll have to take my word for it that that guy with the red stripe on his legs there was me back in December of 1993. And what you see on the left is the Hubble Space Telescope, which I hope most of you have heard about. Um, I actually made 5 space flights, and this was my fourth one where we actually went up and fixed it. That's really another story, which I don't have time to go into detail. What I'm hoping to do is, by way of introducing myself, tell you a little bit about how I became an astronaut, and then um, show you a little bit, to the best I can do with pictures, of what it's like actually going on a space mission. So when I was young, this was a little boy back in the 1950s. There were no real astronauts. The Sputnik wasn't launched until the first satellite was launched in 1957, and the first human beings flew in space, Yuri Gagarin, John Glenn, in the 1960s. So my heroes were actually science fiction. Flash Gordon, Buck Rogers. I was really interested in space even before we started to go there. Um, and back then, there were all these pictures and magazines on television of the future space stations and trips to Mars. And it was an exciting time. Um, and then, of course, in 1957, everything changed. That's really when the space age began. The Russians launched the first satellite, the Sputnik. And then in the early 1960s, they actually selected uh, astronauts, people who were going to go into space. And of course, like young American kids all over, I thought, gee, wouldn't it be great to be an astronaut? But it actually turned out when you looked at all these people, they were all military pilots, and their careers were mostly test pilots. And that was not a career that I was planning to pursue. So I realized that, you know, probably I was not going to be an astronaut, but I was interested in space and I was interested in science. I grew up around New York City and we made lots of visits to the old Hayden Planetarium. Looks a lot different now, but I learned all about astronomy and what the names of all the stars and the constellations and how the planets moved. And then I went to college and graduate school at Harvard, where I got a PhD in astrophysics. And the kind of astrophysics I was interested in was what we call high energy, looking at X rays and gamma rays coming at us from stars and galaxies. And to do this, you have to go put your telescopes above the Earth's atmosphere because luckily for us, our atmosphere absorbs all of this high energy radiation. So there I am back when I was a graduate student. Um, and that's a telescope that I built for my doctoral thesis. And we actually launched that on these big balloons filled with helium that take the telescopes up to about 110,000 feet, you know, about 20, 25 miles above the ground, where they're high enough that they could observe. And I was also very active. I did a lot of skiing, parachute jumping, all of which eventually helped when I applied to be an astronaut. But I was doing it because I just like being active. I like doing cool things and mountain climbing. I wish I had that much hair now, but that was a long time ago. Um, Then I went to do a postdoctoral work at in England at the University of Leicester. They also sent telescopes up, and this time instead of using balloons, we used these small, what we call sounding rockets. You can see me up in the front there with my cowboy hat on. And this is a picture of a sounding rocket, much smaller than the rockets that people ride in, but they're good for taking your telescopes high up, about 100, 150 miles, and they stay up there for about 5 or 10 minutes, and you can make observations. This is a launch of a rocket. Well, now that was much faster than any rocket that people ride. And the other thing, when I was a graduate student, I learned how to navigate using the stars, and I became a navigator on a ship, which we took across the North Sea several times. So a lot of interesting things in my background. And when I finally applied to be an astronaut, of course, all of that experience was helpful in my getting selected. And the most important thing over in England was that I married a lovely English woman, and there's our little 5-week-old son in the baby carriage back there. Then we came back to MIT, which is where I met Lynn Kaminsky, and I was working in the X-ray astronomy group at the time. And at this time now, we put our telescopes not in balloons or satellites, but on our sounding rockets, but up in big satellites. And of course, that meant we needed to use much bigger rockets to launch them. And we had I worked there for 3 years. It was a very exciting time. We discovered where you remember all the work we did on X-ray bursts, Lynn. It was scientifically very exciting. But this was now in the about 1976 when NASA was starting some of the initial tests of what was then this brand new space shuttle, which was a revolutionary vehicle. It was partly airplane, partly rocket. It was designed to be able to fly many times, which nobody had ever done before. And the amazing thing about the shuttle, from my point of view, was they needed only 2 pilots to fly the shuttle, but there were enough seats for 7 people on the crew. And that really opened up opportunities for people who were not pilots like myself, for scientists, engineers, medical doctors, and all the other kinds of people who ended up flying on the space shuttle. So, when NASA put out a call for applications to be a space shuttle astronaut, and they said, yeah, we want pilots, but we also want scientists and engineers. So I applied, and along with about 8,000 other people, of course, there was a lot of competition to be an astronaut. But I was lucky enough to get selected. Um, and by the way, this was our group of astronauts. There were 35 of us, so we called ourselves TFNG, the 35 new guys. And we also had the first women, the first American women astronauts. You can see there is Sally Ride, who was the first American woman in space, along with her colleagues. So that really changed my life. I was no longer doing astrophysics research. I was learning how to fly in space. And of course, the space shuttle was a very complicated machine, and it took several years of basic training just to learn all the systems and how to operate the shuttle. Spent a lot of time in Florida down at the Kennedy Space Center. This is the big vehicle assembly building, originally built during the Apollo program for the Saturn rockets. and then they converted it for the shuttle, and it's still being used for other rockets nowadays. Uh, Originally, we thought that the shuttle would be as easy to operate as an airplane, and this is what people thought it would be like in the hangar. It turned out to be a lot more complicated, and this is what it really looked like with hundreds of people getting the shuttle ready for a launch after each of its flights. But for all the problems it had, the shuttle was quite successful, and in the end, we over the course of 30 years from 1981, when we made the first shuttle flight, to 2011, when we had the last flight of the shuttle, shuttles had flown about 135 times. Um, when you come back into the Earth's atmosphere, it's very hot, and the shuttle is protected by these silicon tiles. And of course, just taking care of all those thousands of tiles was very difficult. One of the reasons why the shuttle never flew as frequently as we had originally hoped. But after a few months of work in the hangar, it's ready to go over to the big assembly building. And this gets really exciting because the shuttle does not contain enough fuel to get into orbit by itself. They need extra fuel tank and some extra rocket boosters. So they hook up this crane and then they lift up the shuttle. And I have to tell you, when you see this shuttle just hanging in the air, it is really exciting. By the way, they test the cranes very carefully before they do this. You do not want to drop a space shuttle onto the ground. And then they bring it over, and that big orange thing that you see that has all the fuel, the hydrogen and oxygen that the shuttle engines use. And then those two white things on the side, those are the extra booster rockets that help the shuttle get off the ground for the first 2 minutes or so. And they lower the shuttle down, and then they hook up the this is the fuel tank on the left and the shuttle on the right. And when we get into orbit, this attachment has explosive bolts which fire, and then the tank falls back to the Earth, and it burns up. Everything else is recovered. The booster rockets and the shuttle itself, we recover. So it spends a couple of weeks getting put together, and then we put it on the launch platform and wheel it out to the launch site. I always like this picture of an early foggy morning in Florida. And there we are up on the launch uh, site. Now, during all this time when they're getting the shuttle ready to go, and this is one of my favorite pictures. We actually had two shuttles, one over here on Launch Pad 39A and another one over here. And you can see a rainbow coming down. This is the Atlantic Ocean over here. But all this time while they're getting the shuttles ready to fly, we as a crew have to get ready to fly. So what's it like to start training for a space flight? Well, uh, it's a bit like going back to school. The first thing that happens is they give you a big pile of training manuals, and we've got to read them and learn all about the different systems on the shuttle. And actually, nowadays, this is really more up to date. Where the astronauts nowadays, of course, we don't have the shuttle anymore. They're going up to the space station, and we work together with the Russians on the space station. So now, if you want to be an astronaut and go up to the space station, not only do you have to learn all of the NASA equipment, but you also have to learn all the Russian equipment, and you have to learn about it in Russian. So part of astronaut training nowadays, which I did not have to do, is studying the Russian language, and you have to pass a test to be at a certain level of fluency in order to qualify. Um, One of the newest things for me was learning how to fly in a high performance supersonic fighter jet trainer. Um, Space flight, in many ways, is an extension of high performance jet aviation. And of course, all of the pilot astronauts knew all about that. But, you know, as a scientist, I knew nothing about supersonic jets. um, but it was sure fun. And it was very good training. We in addition to learning how to read checklists, work with other crew members, deal with emergency situations, it also exposed you to a lot of interesting, physiological situations like being upside down or pulling high G levels in the sun. So that was a big part of the training, particularly for people like me who had not been pilots in the beginning. But most of the training, once you've learned the basics, then you actually go into the simulators and you get to practice everything that you've learned. And you don't just practice when everything works right. In fact, about 10% of your training is learning how to do what you're supposed to do. And 90% of your training is learning what to do when things don't go like you're planning. And so they have people who basically they introduce problems into the simulators, and then we have to learn how to deal with those problems. And you gradually build up your skills and your ability uh, to work when things don't work properly. And that's important because, in fact, on every one of my flights, at least something has gone wrong, and the training for how to deal with these malfunctions is very important. And physical training like how to evacuate the shuttle if there's a hard landing. Of course, I was a mountain climber, so rappelling was not difficult for me. Um, we introduced virtual reality into our training. We were the first crew to do that, and now it's used all the time. And the pilots, they have this motion-based simulator that they use. Um, I've done 4 spacewalks in the course of my career. On my first flight, I did the very first unplanned spacewalk that NASA had ever done in its history. This was a satellite which we launched, which didn't turn on. And so NASA decided to send me and my colleague out to fix it. And then when we went to fix the Hubble telescope, I did 3 spacewalks. But we do the training for spacewalks underwater. And why do we do this? Well, a spacesuit here on the Earth weighs about 300 pounds. Now, up in space, of course, it doesn't weigh anything. You're weightless, and that's not a problem. But if I were wearing a 300-pound spacesuit here on the ground, I couldn't even move around. I could barely stand up. But underwater, the spacesuit, of course, is filled with air. We're breathing it. And so it wants to float up to the surface. And then what they do is they put lead weights on our chest, on our arms, on our legs, just so that they neutralize the buoyancy so that we don't float, we don't sink. And it's the closest you can come to really being in space. And that's how we do essentially all of our training for spacewalks. When we were training to fix the Hubble Space Telescope, we spent about a total of about 400 hours underwater. So it's very, very important training. And then we don't the only way that we can create true weightlessness is by going in an airplane, which NASA has. And this airplane, basically, it's a little bit like a roller coaster. They fly up at about 60 degrees and then they pull over the top. And as you go over the top and then you start falling, uh, the airplane is falling and you're falling inside the airplane. And so as you can see in the lower left, you're truly floating inside the airplane. You're actually falling, but it doesn't feel like you're falling. It just feels like you're floating. And we use that for getting used to being weightless, which is they're just sort of fooling around over at the left, eating their little candy that's floating around. But we also use it to test equipment and go through procedures. I had to go through the entire procedure of getting in my spacesuit, getting into the airlock, and all that while we were in these weightless periods. Each period of weightlessness lasts for about 20-25 seconds. Then the most exciting thing is when you get assigned to a crew. So this is the crew for my first space flight. And we fly down to Florida about a month before launch for a dress rehearsal where we basically go through all the procedures. We get into our launch and entry suits. We take the elevator up on the launch pad. We get into the shuttle. We strap in and we do the countdown. It's good training for the launch control team as well. And then at T0, we declare a launch abort so that we can practice the emergency procedures. From the top of the launch tower, there you can't see it from this view, but there's actually cables which come all the way down to the ground. So if we have to evacuate, we get into these little baskets which are hooked to the cable, and then we cut the restraint, and it's quite a ride down, as you'll see in a minute. Here we go. And when you finally get down to the bottom, you have two choices. They have a bunker underground. Remember, this is if there's a threat, there's going to be a fire or an explosion on the launch pad. So you can go into the bunker and wait until everything is safe, and then they'll come and get you. Or they put at our disposal an armored personnel carrier, and we can get in that and drive far enough away that a helicopter can come and pick us up safely. So we had to spend all morning learning how to drive a tank. That was pretty cool. And they also teach us how to fight fires because there's a lot of flammable stuff at the launch pad. And just in case, if you do things right, you can use that spray to actually allow you to get through a fire that otherwise you couldn't penetrate. Then we go back. This was a month before launch. Then we go back to Houston, 3 more weeks of final simulations. Then we fly back down, and a week before launch, you go into a medical quarantine. And the reason for doing that is they don't want us exposed to common cold germs, so that they don't want us to get sick when we're up in space. Um, and this is a very emotional time because you're getting ready to sit on top of a loaded rocket, and people have different emotional responses to that. There's obviously a certain amount of danger involved, and everybody has to deal with that in their own way. And it's really nice. It's on the coast, and it gives us just a little bit of free time to walk up and down on the beach, and I really enjoy those last few days. And then the very night before launch, they roll back the towers and they light up the shuttle, and we all go and look. It's very impressive. And then the morning of launch, we get up early. We have a light breakfast, get in our launch and entry suits. These are pressure suits, so that if on the way up, if the shuttle or whatever your spacecraft is should lose pressure, you'll survive and you can hopefully bring it back to the ground. And then also the material in the outside is resistant against flames and all the hazardous chemicals that they have around the Cape. Then we walk out to the transport that brings us to the launch pad. And this, as I say, is very emotional. You look up at that big spaceship that you're going to get in pretty soon. And so here we are. And at this point, there's almost nobody on the launch pad. We take the elevator up And then this is the platform. We call this the white room, and it's attached to the hatch of the shuttle. And there's just about 3 technicians up there who help us finally get into our suits, strap into the seats, close the hatch. You can see the hatch there in the background. And then they leave. And now we are all alone, just sitting up here. And then finally, countdown to 0. And we are on our way. And I have to tell you, it's much, much louder than what you could hear on the loudspeaker. The whole ground is shaking. And I mean, inside the vibration and the noise is just tremendous. People told me before my first flight, they said, imagine the most vibration you can imagine, and it's going to be worse than that. And sure enough, everything was shaking. And um, this is the most of the power to get off the ground comes from these booster rockets. And that's where most of the vibration is coming from. But it's an amazing sight. I mean, you're going straight up. You basically you break the sound barrier going straight up. You can see why we call this riding the fire. And there we are on our way up to space. And when we break the sound barrier, you get these extra shock waves, and that made even more vibration. So it's very dramatic. I have to tell you, launching in a rocket. Every rocket is different. The shuttle had certain characteristics. Nowadays, they launch on the Falcon rockets, but it's always exciting, no matter what you're doing. You've harnessed a tremendous amount of power because you have to overcome Earth's gravity, not just to get high up into the above the atmosphere, but after 2 minutes, when we drop those booster rockets, our engines have to keep firing because although we're above the atmosphere now, we're not going fast enough to stay in orbit. If you're not going fast enough, you'll fall back down to the Earth. So we have to keep firing our rockets until we're going almost 18,000 miles an hour. That's 5 miles every second. So think of being able to fly from um, San Francisco to Los Angeles in about 5 seconds or so. It's pretty amazing. And then finally, we're in orbit, and everything looks different when you're up there. A few things I want you to look. This is the Straits of Gibraltar. So this is the Atlantic Ocean here. This is the Mediterranean Sea. This is Africa. This is Spain and Portugal on the left. And look at the horizon. Do you see this very, very thin blue line? I want you to go outside if it's a nice day and you look up at the big blue sky, and it looks like the blue sky goes on forever, doesn't it? But really, this is what our Earth is like. The whole atmosphere of the Earth is just really, really thin. Once you're up above 20 miles, you're up above almost the entire atmosphere. So anytime anyone tells you that you can put anything you want to into the atmosphere and it's not going to make any difference, think back to this picture. The atmosphere is very, very thin, and we really have to take care of it. I told you I love mountains, so I took a lot of pictures of the Himalayas every time we flew over it. That's Mount Everest down below. And I've seen the Himalayas from the bottom when they look really, really high, but when you look down at them from space, somehow they don't look quite so big after all. And as I say, you're going really fast, 18,000 miles an hour, but it doesn't feel like you're going fast because there's no vibration, there's no wind noise, there's no billboards or trees going past your window. But here we are flying over San Francisco Bay, and then 10 minutes later, we're flying over Cape Cod. So we've gone from the Pacific Ocean to the Atlantic Ocean in 10 minutes. And then another 10 minutes, we've crossed the Atlantic, and there's Ireland and Great Britain. So in your mind, you know you're going really fast, but it really doesn't feel like you're moving very fast because all the things that normally we associate with motion, you just don't feel up there. What does it feel like? Well, the first time that you become weightless, it feels a little bit like you're hanging upside down because the blood rushes to your head. The gravity isn't pulling the blood down to your feet anymore. And so it rushes to your head, and you get this feeling of fullness in your head. And notice I have my eyes closed here. You have no sense of up or down. Everything that normally tells us which way is up or which is down. Obviously, if you open your eyes, you know what direction you are, but the organs in your inner ear, which work here on the ground, or, when you're standing up, you can feel on the bottom of your feet that you're standing. None of those things work in space. So there's this confusion about your position, and that actually causes kind of a space sickness. About half the people who go up get anywhere from mild to severe space sickness, a little bit like seasickness or air sickness. You get over it pretty quick, and we have good medicines, but it is a somewhat stressful transition to go from being on the Earth to being in space. And, my spinal column fills up with fluid, and I grow I'm 6'2" here on Earth. I was 6'4" in space. And stretching your spine by 2 inches can cause a lot of back pain. So, people get headaches from the extra fluid in your head and back pain. But after a day or two, you're pretty much used to it, and everybody just really enjoys being in space. A lot of people ask about space food. This is the kind of food that the original astronauts ate way back in the early days, but things have gotten a lot better since then. We have meals ready to eat and dehydrated food. It's sort of the kind of food you'd have if you go camping. And we have a lot of international astronauts now, so we get space food from Japan and from China and from France. And so the food is not nearly as bad as some people think it is. Although, you don't go into space just to have a gourmet experience. The most important thing about food is you don't want crumbs, because crumbs on the Earth fall on the ground and you can vacuum them up. In space, crumbs just float around and you can breathe them in. And so we don't even usually use regular bread because it has too many crumbs. Tortillas work really great. And by the way, you can see Sandy here is having a bad hair day. Every day in space is a bad hair day if you have long hair. And in general, the women with long hair have to keep their hair under control because otherwise it's a health hazard. But it's always nice to get a picture with your hair floating all over the place. And of course, eating, um, we don't have early shifts or late shifts, but we have the ceiling shift and the wall shift and the floor shift. So you get used to being doing things in very different ways when gravity isn't pulling on you. And then, of course, you have the toilet, which is very complicated because there's no gravity to get everything down. And I could spend a half hour explaining to you in detail how to use the toilet. The most important thing, though, is you need a seatbelt so that you don't go floating up when you're in the middle of doing your business. That would be very messy. And these are the small bunks that we sleep in. It looks very claustrophobic, but somehow without gravity, when you're floating, you don't feel that same sense of claustrophobia that you otherwise might do. And I just never got tired of looking out the window at these beautiful sunsets of all the different layers of the atmosphere. You can see the moon and Jupiter up there, and the just beautiful views. We flew right through the aurora. It's at the same altitude as the shuttle would fly. So, sometimes people would ask me, what did I do in my free time? Did you read a book? Did you watch movies? No, I just looked out the window. I never got tired of it. And I love the mountains, as I said, and in some ways, there are similarities between mountain climbing and going into space because, you have to take a risk. You have to do a lot of work to get up to the high regions, but once you're up in the summit, it's a different state of mind. You're isolated from everything that's down below, and somehow your vision is expanded, and of course space is higher than the highest mountain, and so those feelings are magnified. And when I talk about the different perspective in space, the best way of illustrating it, I want you to look at the picture of the sun up there in the upper right, because you've never seen the sun like this before. And I don't mean those rays coming out, that comes from the lens of the camera. No, what I mean is every time that you've seen the sun, it's in a blue sky. Think about it. Um, and the reason it's in a blue sky is because we're below the atmosphere and the air scatters the light, and that's why the sky is blue. But up here, there's no air. And so you see the sun as it truly is, as a star in a black sky. Of course, it's closer than all the other stars, so it's bigger and brighter. But that's the sun as it really is, as a star. And just finishing up, um, I talk a lot about zero gravity and what it's like floating weightless. It's almost impossible to describe in words the sensation. We try to share by pictures how totally different life is up there in space. One of my crewmates was an amateur juggler, and he told us how, since time immemorial, the dream of jugglers was to make it appear that the balls were suspended motionless in space. Well, here you can actually do it. And this is my magic carpet, and it's not photoshopped. So space truly is it's a new world. You experience things that are just so totally different from anything that we experience on the ground. And it's I never get tired of showing these pictures and talking to new people about them because it kind of brings it all back to me. And that's the picture I'll leave you with. Again, this was on the mission where we fixed the Hubble Space Telescope, because there we were about 400 miles above the Earth, just hanging out, and it's a new world up there. And of course, these days with commercial space flight, many more people are flying in space than did when I was there. And it's an incredible experience, which I hope that I've succeeded in just at least a little bit sharing with you what it's like preparing for a space flight, and what it's like when you actually go up into space. And with that, I think we have about 15 minutes, and I'd be happy to take any questions that any of you have about what I've talked about.
Wow, that was great. We have a lot of questions in the chat that I couldn't answer because I've not been an astronaut. I can answer the science questions, but not questions about what it's like to be in space.
Okay, well,
I,
why don't
if I go back to the questions,
yeah,
that I couldn't answer.
why don't you select the questions and
uh,
read me, and I'll do my best to answer them.
Okay, so I think the first question I couldn't answer was from Oliver. What does being under all that force feel like?
Um, Actually, the space shuttle only pulled about 3 times the force of gravity. So that's we call that 3 Gs, which any healthy person can tolerate 3Gs. It's not particularly comfortable. I mean, you're pressed back in your seat. Other rockets are a lot more stressful. They'll take you up to 5, 6 Gs. It's just something you have to put up with. I mean, they give you comfortable seats to sit in, and in fact, in some spacecraft, the seats are custom fitted to your body, and that makes the G forces easier to tolerate. It's not particularly pleasant, but it's just part of what you have to do to get into space.
Okay. Sid asked when you were showing the picture with the shockwave around the nose of the shuttle, is that a sonic boom?
Yeah, it definitely, but the thing is, you're going straight up, so they don't really hear the sonic boom back on the ground. On the other hand, when the shuttle came in for a landing, you definitely heard the sonic boom as it went from supersonic down to subsonic. And because the shuttle is so big, you got one shock wave from the nose and another shock wave from the tail. So when the shuttle would fly overhead, it would go and you would get a double sonic boom.
Wow, cool. Okay. Maria asks, I've heard that astronauts who see Earth from space have a big realization or shift in their mindset. And have you experienced this?
In some sense, and why do we think that's true? I'll give you my thought on that. Um, I'm sitting there looking out the window of my spacecraft, and I realize that on the other side of the window, it's a vacuum. If I were out there with no spacesuit, I'd be dead in less than a minute. And then it sort of hits you that, most of the universe is completely hostile to life. I mean, almost anywhere you go in the universe, you'd be dead. And then you look down at this beautiful blue and green and white and brown planet, the Earth, which gave birth to life and preserves life. And it really, you really appreciate what an amazing planet we have and how lucky we are that the Earth is the way it is, and sustains life. Otherwise, we wouldn't be here. It's something that intellectually we all know, okay? But it's one thing to know something intellectually and another thing to actually experience it. And that's why I think that so many astronauts talk about this change in their feeling about the Earth, because you see it from the perspective of the hostile environment of almost all of the rest of the universe.
Okay. Did you have, this is from August, did you have trouble adjusting to gravity back on Earth, like trying to leave things in midair like you can do on the space station?
Well, I was very careful. The first problem I had, when you're eating, um, I'll eat and then I want to have a drink. So I have my cup down here. I don't have to put my food spoon down on the table. I just let go of it and it floats. And then I take a drink and then I grab my spoon again. So what do you think I did the first meal that I had when I came back from space, after my first space flight, and I wasn't thinking about it? Yeah, I was eating my salad. I wanted a drink, and so I just let go. And of course, the fork fell on the floor, and my wife laughed at me, and I never made that mistake again. Um, but basically, we've grown up on the earth, and your body remembers very quickly what it's like to be back in gravity. Now, on the space shuttle, the longest we ever stay up was about 2.5 weeks, and your body doesn't change that much. When people are spending 6 months to a year on the space station, they actually have to do a lot of exercise, physical exercise, to keep their muscles strong. Because if you don't do that, um, when you get back on Earth, you'll just be you lose a lot of muscle weight and bone mass. So it's very different long duration space flight from what we did on the shuttle. And it's a lot more difficult to get back to gravity the longer that you've been in space.
Okay, we have so many good questions that are coming in. It's hard for me to pick. Akutan asked, was data analysis or data science and remote sensing ever part of your job? And if so, how did you help apply it for NASA?
We did have a lot. We took a lot of experiments on our different flights. Mostly, though, the data we would operate the instruments, but then the data would go directly down to the ground. So we didn't actually do any real data analysis ourselves while we were up in space. These were experiments designed by and large by scientists who stayed on the ground. And our job was to operate the experiments, collect the data, but then the data went directly down to the ground for people to analyze down there.
Okay, Evan asks if you experienced any unusual phenomenal sounds in space.
Phenomenal what?
Sounds. I mean, there is no sound in a vacuum, but maybe he means sounds when you were in the shuttle.
Um, th- well, there actually there is a peculiar noise inside a spacesuit. Mostly, it's the fans that are going that circulate the air. And one of the things that they do as part of our training is before we go into space, we get in our spacesuits and we go into a vacuum chamber so we can get used to what it feels like and what it sounds like. The other thing inside the shuttle, and this is true about all spacecraft, there's always fans running. And the reason is in space without gravity, hot air doesn't rise. Hot air here on Earth, hot air rises because it's less dense and so it's lighter than cold air. But in space, nothing weighs anything. So hot air is no lighter than cold air because neither one of them has any weight. And therefore, air doesn't naturally circulate. So you really need fans going all the time. So it's not really quiet when you're up there. There's always this high-pitched white noise of the fans going, and that's really the sound of, I wouldn't call it the sound of space, it's the sound of a spacecraft, of being inside a spacecraft.
Okay, like we have time for one more question, and we have our guest Katerina from the European Space Agency, who's starting a neurodiversity group with that space agency, sort of following in our footsteps. And Katerina is wondering how might neurodiverse thinking styles benefit during spaceflight, and if you've worked with any crew members who identify as neurodivergent.
Neurodivergent, I don't have experience with, but there's a lot of interest in making space flight available for people with many different types of physical and emotional conditions. One of my students is diabetic, and he did an experiment on the zero gravity airplane to see if his insulin pump would work in zero gravity, because that would make it possible, in principle, for people with diabetes to go into space. And sure enough, it worked just fine. Um, so yes, there definitely is an interest in trying to make it possible for not just astronauts in 100% perfect physical and psychological condition to go into space, but as many different types of people with all sorts of different neurological and physiological conditions. And I think that's great. I mean, the environment of space, it's a new world, and it's a world which it changes your view about life on Earth, and the more people who can experience it, I think the better. So I'm all in favor of doing everything we can to open space flight to as many different people as possible.
All right, well, thank you so much. We have a few minutes left to do our evaluation that we have to do every once a month anyway for our program. And I'll turn it back over to Ariana for that. But let's all give a wonderful round of applause to Dr. Hoffman for sharing with us the such exciting tales of his time in space.
Okay,
So,
well, I'm glad we could do this, Lynn. Great to see you again.
yes, thank you so much. We really appreciate it. And we'll be posting the video on our website for people to watch.
Great.
And I'm sorry we didn't get to